Welcome back. Let's explore functions in Python. In programming, a function performs an action, or perhaps multiple actions. Essentially, they're reusable chunks of code that allow you to perform one or more actions however many times you need. We use a function throughout our exploration of Python so far. We've used the type function to look at the underlying type of various values. For example, the type of the number 3 returns the class int. Likewise, a type of 3.0 returns the class float. And now a new one, the type of a string, for example, of 3 returns str, which is short for string. Overall, the type function performs the action of calculating and returning the type of some value in Python. Because it's a function, we can use it over and over again using its calling syntax. Another useful function is the len function. This one returns how many characters are in a string. For example, we can get the length of the string hello or the string hi. Cool. Now, in order to define your own function in Python, you use the def keyword. This produces what is called a function definition. Use the def keyword and then go ahead and name the function greet. After naming the function, you provide a pair of parentheses and a colon. Next comes the body of the function. So make a new line and be sure to press tab to make an indent, rather an indent. The body of the function consists of any number of lines that we'd like. This body defines the action of the function. And for this greet function we're creating, let's use the global print function to print the string aloha. So that's a greet we haven't used yet, and there it is, print aloha. Press enter twice and the function is going to be completed. And you can tell it's completed because we have the same greater than sign print as before. Now that we have this greet function, you can call it as many times as you want. So go ahead and execute greet, and we have the print of aloha. Very cool. Press up and execute it one more time, and nice. All you have to do to invoke the function is use that pair of parentheses. However, invoking the greet function without the parentheses causes an entirely different thing to happen. This returns a function as it's stored in the memory of the program. Notice that it has an address and everything, which is that string of numbers after 0x. The address of a function is a rather low level of detail in Python programming. It's actually not really going to ever appear again throughout this course, so it's not something you really need to worry about unless, well, you're developing the Python language itself. But it is highlighting a really important point, the fact that functions are objects. In fact, this is part of an even larger and crucial truth about Python. Almost everything is an object. So because a function is an object, think of the function as a tangible part of the program like any other value. Because a function is an object, like a number or a string is an object, we can assign functions to variables as well. For example, we can rename this greet function to aloha using an aloha variable. So aloha equals greet. And now calling the aloha variable will also call the original greet function. As we continue to explore Python, we'll explore more of that critical point that almost everything is an object with more examples. To continue, we can build more useful functions by giving them arguments. A function can have arguments by adding input values within the parentheses in the function definition. For example, we can have a function called double that has one input value, x. So in a pair of parentheses, have x and then the colon. For the body of the function, this time let's calculate x times 2, and actually let's return x times 2 using the return keyword. So go ahead and make the new line a couple times, and now when you call double, you can add an argument. Let's give it the argument of 3, and you'll find that the return value is 6. Nice. We can assign the result to a variable, like we did before, so 3 doubled is going to be equal to double 3. And if you access the value of 3 doubled, it will be the result 6 as well. By the way, notice that I decided to use an underscore in my variable name. I decided to use the underscore in order to create a longer name that consisted of more than one word. This convention is called snake casing. since the longer the variable name becomes, the more it starts to look like a big snake on your screen. Okay, moving on, not all functions are going to have a return value like our double function. In fact, our greet function is an example of a function that doesn't have a return value. If you try to assign the result of calling greet to a variable, well, you're going to get something interesting. So assign the variable greeting to the result of calling greet, and indeed, calling greet does perform the print of aloha, but this isn't the return value. If you check the value of greeting, well, you're going to find that nothing is printed to the console. So overall, the double function and the greet function are demonstrating an important distinction about functions in general. The double function that we have is one that doesn't have any side effects. The whole body of the function is relevant to the return value, whereas the greet function completely consists of side effects. It only does a print, which is non-relevant to the return value. It doesn't affect what greet returns. In general, it's a best practice to make sure your functions have the least number of side effects possible. It's okay to have a few prints here and there, but as programs grow, certain side effects become large and hard to untrack, making the code unpredictable and buggy. Let's not get in too long of a tangential programming discussion though, let's continue exploring functions. For the last function, let's create one that does both a return and has side effects. So let's go ahead and declare a function of multiply with two arguments, a and b. Don't forget the colon at the end. Alright, with a tab, have a variable called result that multiplies a and b. So set result equal to a times b. Then for the side effect, let's print a string that says the result is as the first argument. So the string is the result is, and then as a second argument, we're going to have the result variable itself. So this is going to be the side effect, the print statement. But now on another new line, we can return the result. Okay, so after a couple new lines, we have the overall multiply function. So let's go ahead and make a result of 2 and 5 multiplied. So we have this variable equal to calling multiply and then passing in 2 and 5. All right, and we see that the result is 10 printed to the console, and that was the side effect of the multiply function. But now we can also get the result of 2 and 5 multiplied, and what we have is the resulting value, which is the direct result of the function. If we didn't have the print statement and no side effect, multiply would have been a pure function. However, again, the print statement disqualifies that. As one last point, notice that we created a variable result within multiply, so let's see if we can access that outside of the function. If you type in result and press enter, well, you get a name error explaining that the name result is not defined. This is demonstrating an important aspect about functions. They create their own scope, meaning they create their own isolated environment where if they define a variable, only the function itself is going to have access to it. So the result variable was declared in the multiply function, which means that the function itself will have access to the result variable during its execution. However, that variable is isolated to the function only. It doesn't become available outside, which is why we can't access the result variable in this regular prompt. Okay, with that, we have a pretty good grasp on functions. Next up, let's take a look at control flow with booleans, comparison operators, and if statements.